March week 1, math, 3rd grade, lesson 3, patterns. A pattern is an ordered set of number shapes or objects. There are many different kinds of patterns, and some patterns may increase. Each number in this pattern is 3 more than the number before it, so the rule is add 3. Some patterns may decrease. Each number in this pattern is 2 less, so the rule is
2. Take away 2.
Subtract 2. Good. An odd number is a whole number that has a 1, 3, 5, 7, or 9 in the units. They say ones. Gideon, no. An even number is a whole number that has a 0, 2, 4, 6, or 8 in the units. And again, they're saying ones. Notice that the numbers in the decreasing pattern are all odd. And the numbers in the increasing pattern alternate between odd and even. 2 is even, but 5 is odd. 8 is even, 11 is odd. 14 is even, okay? They're going to be asking you to look a lot at odd and even.
17 is
all right? So we're going to have fun with odd and even. Let's go to the next page. What number pattern do the tiles below show?
2, 4, 6, 8.
Okay, so describe the pattern.
It's going up by 2.
Is it?
2 by 2.
Is it adding 2?
Yes.
No.
2, 4, 6, 8, 10, 12, 14.
So what's the rule?
It goes by 2.
Plus 2. And they've got that right here. Okay. Then the last thing they want you to do is analyze the pattern. Did you all circle add 2?
Yeah.
Okay. Analyzing the numbers in the pattern, can anyone tell me something about the numbers? Are they all odd? Are they all even? Do they alternate?
They're all even.
They're all even. And they have that right there. Go ahead and circle that. Okay, so the rule is add 2, and they're all even.
Yep. 2, 4, 6.
Next page. In an addition table, the atoms are in the first row, which is here, and the first column, which is here. Okay, those are the atoms. And then the sums fill up the rest. You can find numbers in an addition table. The shaded sums on the addition table, these are lightly shaded. You see that? There's a diagonal and a horizontal line. The shaded sums in the row for 3, so that's here, this horizontal line, shows a pattern. Each sum is 1 more than the one before it. It is a growing pattern. So look, 3, 4, 5, 6, 7. Okay, it's growing by 1. Also notice that the sums alternate between odd and even. Okay. The shaded sums in the diagonal, that's this one, show another pattern. Look at each set of addends that make a 10. Other than 5 plus 5, there are 2 sets that use the same addends, just in different order. That's the commutative property. Do you guys remember? So look, let's just, for an example, let's do 9 plus 1. And I'm going to start here in the column and go here. But then if you come over here to this 9 and do 1 first, 1 plus 9, it still makes 10. So they, commutative property, guys, remember that? They flipped the addends. They flipped. Now, we did commutative property, but we didn't do it with adding. We did it with multiplication. We were flipping factors, remember? They're flipping addends. So here they're showing you how to do that. 0 plus 10 is 10. 10 plus 0 is 10. 1 plus 9 is 10. 9 plus 1 is 10. 2 plus 8 is 10. 8 plus 2 is 10. And so on. And then, but look at the last one.
5 plus 5 is 10.
How come you can't have a second way of saying that?
Because
they're the same.
Because the addends are the same. Yeah.
10 plus 5
How can you flip them if they're the same, right? You can't. Next page. Go ahead and
Oh, you actually can do it. 3 plus 2 plus 5 is 10.
You could do that. Good. That's the distributive property, though. You're taking that 5, one of your addends, and you're distributing it. Okay. Yes. Look at the shaded sums in the diagonal. What pattern do you see?
2s, counting by 2s.
Good. Going up by 2. It's adding 2. Good job. So they went ahead and wrote down every single one and said, look at each set of addends. For each sum, the addends are the same. So these are all doubles facts. Okay. Analyze those sums. Since the facts are doubles, all the sums are even numbers. All right, that's on this diagonal line. What they're saying is, if you do the 1 and the 1, it's going to go to the 2. The 2 and the 2, it's going to go to the 4. Okay, so that's why they're doubles facts. The 4 and the 4, the 5 and the 5. That line represents doubles facts. Everybody got it? Okay.
No.
And next page. In a multiplication table. Uh-oh, Gideon.
Oh no. Oh man.
Need to go to the same page as Miss Cammie. No.
You're still on the
Give me your sheet. No, give it. Come on. Thanks. You went too far. Right here. In a multiplication table, the factors are in the first row and the first column. So no more addends, factors, okay? This is a multiplication table. That's why there's a little time sign up there in the corner. The products fill the rest of the table. You can also find many number patterns in a multiplication table. Look at the shaded products in the columns. What pattern do you see? They, first of all, are going to do 2 times 1. So that's from here to here is 2. 2 times 2 is 4. 4 times 2 is 8. And so on. They're also doing a bunch of other ones. Let's go to 6 times 3. Put your 6, put your finger on the 6 and the 3. And they've got 6 times 3 is 18. Except that's over here. Sorry, let's do shaded. They want us to go on the shaded ones. Let's do 5 times 10.
20.
50. Let's do the last one. 10 times 10. 100. Okay. And they want us to analyze products and factors. Let's go to the next page and look how they do that. They're going to say, and what I want to do actually is leave that multiplication table up while we analyze. So I'm going to borrow this one because Griffin's not here, so we can use his, and keep that up. They want you to look at each set of factors. Except for zeros in each set, either one or both of the factors are even numbers. Is that true?
Yes.
Yeah. Okay, so like if you go to like this shaded column and pick the 5, which is odd, well, the 2 is even. Do you see that? Do you see anything in this column that has 2 odd factors? Like a 7 and a 5 or a 9 and a 3?
No.
No. The reason they're all even is, look,
On 2.
one of the factors is 2. Okay. The reason these are all even is one of the factors is
4.
4, and so on. So one of the factors is always even, and sometimes one of them's odd, but a lot of the time both of them are even. Please don't do that.
So sometimes when the factor starts on an even number, it keeps going on even numbers.
Well, I think you're noticing the pattern. You're saying as long as one of the factors is even, the products are even. Because look at all your products, guys.
Because even plus
None of
even
them are
equals
odd.
even.
Well, it's not plus.
Non-even
Whoa,
equals even.
easy, buddy. Please don't do that. This is not plus. Don't say plus. What is this?
Times.
Times. So, what Silas said is correct. Silas said as long as one of the factors is even, thus the product is even. As you can tell by looking at all those different products. And they say that right here. So go ahead and circle that, because that is a good rule to know.
The whole sentence.
That right there. When only one factor is even, the product is always going to be even.
I'm just imagining we didn't have numbers. yet.
Gage, we got that by looking at page 80, but then we turned to page 81. Could you flip over to page 81, buddy?
Yeah.
And circle this. It's a very important concept in math. This is not a plus table like the others. It's a times table. Gage, look at me.
Yeah.
Times. This is a times one. We have factors instead of add-ins. Look. Factors. And we have products instead of sums. So the rule is, Gage, as long as one of the factors is even, all the products are even if the other factor is not even. Can you see that?
Yeah.
Okay.
So it's a times one.
It's a times one. And this is a rule for times, not for plus.
So 4 times 4 is 16.
Yeah. But now do 3 times 4.
12 plus 12.
And see, the 3 was odd, right? One of the factors was odd. The 4 was even. You said 3 times 4. But all you need is one even factor, and the product
Okay,
will
what about
be
5
even.
times 3?
An odd makes even.
Yeah.
Odd and even makes
Well, we're going to talk about
What
that.
about 5 and 3?
Odd and odd makes
Okay.
even, but not with times. You're talking about plus.
Yeah.
We're on times now, okay? So with plus, yes. Let us go to example 4. What pattern was used to make the list below? 7, 14, 11, 8, 5. Well, it's going down, right? So it must be, is it adding or
No.
Timesing.
timesing? Is it?
No.
Numbers get bigger when you add and times them. Are these numbers getting bigger?
Yes.
Yeah.
17, 14,
No.
11,
No, they're going
8,
down.
5.
I thought it was going 5, 8, 11.
Okay,
14.
please don't count them backwards. Let's start at the beginning. 17, 14, 11, 8, 5. Are the
Let's go.
numbers getting bigger?
No.
No.
So could it be times or plus?
Plus.
Take
No,
away.
it cannot be times or plus.
Take
It
away.
has to be division or take away.
Take away by
It's taking away 3. The rule of subtract 3 was used to make this list of numbers. Next page. Page 82. This is a partial times table. Look at the shaded products in the rows. So this time we're going in rows. You see those? What pattern do you see?
I see.
They want you to list the facts for one of the rows. Which row shall we do? Ruben?
9.
Which
No.
one?
There's no 9.
Oh yeah, there is. The four,
Well,
the
I
5
asked
row.
Ruben.
The 5s.
It says list the facts. Well, how come you guys are not doing this?
What's the
Oh.
5, 10.
All the way to 50, Gideon.
And done.
Ruben, we're waiting for you. Everybody's done except you, honey. Okay? Now it says, look at each set of factors. So for the first one, 5, we have 5 and 1. Those factors are both what?
Odd.
Odd. The next one, 10, we have 5 and 2. No,
Nope,
they're not both
10.
odd.
Oh, wait.
One's even and
Well,
one's odd.
The 2 is even and the 5 is odd.
So that means
Now go to 15. Look at its factors. They're both
3.
3 and 5. They're both what?
Odd.
Odd. Now go to 20.
it's
4 and
5 and
5.
5.
It's 4 and 5.
20.
Even, one odd.
One of the factors is even and one's odd. Okay.
It's a pattern.
So it says, look at each set of factors. What do you notice about each set of factors? So
It's a pattern.
they are odd and odd, or odd and even, right?
Yeah.
But there's no even and even. Please write that. Good.
The package is
Analyze the products. What do you notice about the products? You wrote them down. Analyze them. What do you notice about them? What do you notice about them in regards to being odd or even?
They're both odd.
Look at the products. 5, 10, 15, 20. You wrote them down. What do you notice about them?
it goes odd, even.
Good. Alternating odd and even. So they alternate odd to even. Now, it says, when two factors are odd numbers, the product is,
An even.
is it?
Yeah.
Really? Okay,
No,
look at
yeah.
5, the first one. Look at its factors. 5 and 1.
Yeah, no.
They're both odd.
Odd.
Okay.
So they're both
odd.
odd.
Now go to our next odd product. What is it?
15.
15. Look at its factors.
It's a 4.
5 and 3. 5 and 3. Don't say 4 gauge. Put your finger on the 5 and on the 3. Bring them together and you should be on the 15.
15, yeah.
So 15, its factors are both
Odd.
odd. Go to the 25. There it is. Find its factors. 5 and
5.
5. Those are both
Odd.
odd. So when two factors are odd, the product is
Odd.
Okay, good. This is different than adding, because if you add two odd numbers, you get an even, right?
Mhm.
Not the same with times, is it?
Yeah, like
Not the same.
Backwards.
Backwards.
That's what I was thinking.
Now let's go to this sentence. When one factor is an odd number, the product may be
even.
It may be even. For example, 5 and 2, right? 1 is odd, the 5. The product is even. Okay, so we're going to put even.
Or
But when one factor is an odd number, it can also be odd because if the other factor is odd, right? So over here we're going to put or an odd number because
Yeah, it could be
you
even.
could have one factor plus another odd factor. So that's something you need to be aware of. If one of the factors is odd, your product could be even if the other factor is even, but it could be odd because the other factor could be odd. Yeah, Silas.
do you know where odd and even came from?
No. That's a great question. I'll have to look into that. Let's go to page 83. Find the rule for each pattern. Use a word and number from the box. A. And by the way, are we going to write that or just write a plus and a takeaway?
Plus and takeaway.
Okay. 10, 8, 6, 4, 2.
Nope. Subtract.
Definitely subtract.
Go to the line.
It's minus 2.
2. Okay. Oops. I almost circled add. Sorry. Subtract 2. Okay, the next one.
Add
0, 10, 20, 30.
Add
Gideon
2.
says it's adding. He's right because
Add
the
10.
numbers are getting bigger. Adding 10. Okay, so this time I do get to circle add. And we're going to write plus 10. And the next one?
Plus 4.
3, 7, 11, 15,
Plus.
19.
Plus
It's
4.
definitely a plus.
What they said.
Plus 4.
Next is minus 3.
Minus 3.
16, 13, 10, 7, 4. It is
3.
takeaway and it is 3. Good job. Now, please note, this is not a times table. What is it?
Plus.
It's an addition table. See that little plus sign there in the corner?
Yeah, and if you do 7 times 7, 14.
Yeah. 7 times 7 is not 14, right?
I mean,
7
plus
plus 7.
7 is 14.
Use the addition table below. Select true or false for each statement. A. The sums in each column show the pattern plus 1. Look at each column. True or false?
True.
Yep. B. The sums in each row show the pattern subtract 1.
No.
No.
Very false. C. A row for an even addend. So pick an even one. Let's do 4.
4.
Yeah,
5.
4.
No, 5 is odd. Let's do 4. 4
4
or 6? Which one?
6.
6. Okay. So now, a row for an even addend only has even sums.
No.
Yeah.
Yes.
False.
No, false.
False. A lot of those are odd.
It could be a pattern mistake.
Yeah.
Couple.
And then let's look at D. A row for an odd addend.
You pick it.
7. Only has odd sums.
False.
False again.
False.
Because
Okay, no
I
padding.
just did 7 at the beginning. 7, 14.
1 thing.
That's because remember what Reuben said at the beginning. He said if you add 2 odd numbers, you get an even, which is kind of different than multiplication. With multiplication, you can get an odd. It's if you multiply an odd by an odd, you're going to get an odd.
Yeah, like 5
If you multiply an odd by an even, though, you'll get an even.
Like 5 plus 3 equals...
If plus an odd and an even would equal an odd.
Good. You're starting to see that. Did you all hear that?
Yeah.
If you add 2 odds, it's even. If you add an odd and an even, it's odd.
And
if,
Finally, what if you add 2 evens?
If not,
It's even.
even. 2 odds.
Okay, number 3. Which statement describes the pattern? Mark all that apply. Okay, 1, 9, 17, 25, 33, 41, 49, 57, 65, 73.
all numbers are even.
A, all the numbers are even.
No.
Certainly not. Are any of them?
Wow.
Wait, you
I just
circled that.
marked it. Oops. Do not mark it. Back. B. The rule is subtract 8.
No.
No way, they're
It's
growing.
plus in
Yeah.
8.
C. All the numbers are odd.
Yes.
Yes, we can finally fill in a circle.
One.
D. The rule is add 9.
No. He's wrong by 1.
No.
No,
Oh,
he's
well.
wrong
Pretty
by,
close.
he's wrong by 1.
E. The pattern for the tens digits is 19753.
No.
Well, let's look. We've got a 1 and
Yes,
a 10.
it is. Yes, it is. It is.
And a 2.
No.
And a 3.
Not really.
No.
So, no. E. The rule is add 8.
Yes.
True.
So it's C and that
It's a
way.
pattern.
Yeah.
It's a pattern.
It is.
Wrong.
No, right. No, right.
Wrong, right. Okay. Sorry about that. 4. Think about multiplication facts. Choose the correct word to make each statement true. The product of two something numbers is always even.
2 even.
Product of two even numbers is always even.
I was about to say odd.
Okay. Remember, if we had picked odd there, just think in your head, just pick two odd numbers and multiply them. 5 and 3, 15. That product is odd. So that's the quickest way to check.
Wait, never mind. It is even.
Let's do the second one. The product of two odd numbers is always the product.
Even.
Did you
Even.
get
I mean odd.
Oh, odd.
They didn't say the sum, right? The product, which means you have two times, it's always odd.
When they
Okay.
said even, I just had to say even for some reason.
All right, last one. The product of an even number and an odd number is always
In even number.
yes.
Ruben just said it a second ago.
The product of an even and an odd, even if there's only one even, and the other one's odd, guess what? Product is going to be even. Do 2 times 3.
2 times 6.
6. It's even. Okay? One of those factors was odd. The 3 was odd. So just do one in your head. If you're ever stuck on these, you can do one in your head and go, Next page. Mrs. Brill wrote the pattern below on the board. 6, 11, 16, 21, 26, 31. Ramon said Mrs. Brill used the rule add 5 to make the pattern. Aaron said Mrs. Brill used the rule subtract 5. Who is correct?
Ramen.
Ramon.
Salmon.
Ramon. So the boy. What mistake could the other person have made? It's something you guys did earlier.
Go backwards.
Started at the end of the pattern, so went backwards.
Could we just draw an arrow going that way?
Yeah, sure.
I said 60 instead of a G.
There. That's what I
So
did.
they started on the right and went
That's why I just drew an
supposed to go what? Left to right. 6. This model represents the sum of two odd numbers. 3 plus 3.
Yeah.
2.
Part A. Draw models to represent the sum of 3 plus 4, 4 plus 4, and 4 plus 5. Okay, I'm just going to do blobs.
That's equals 7. 1, 2, 3, 1, 2, 3, 4.
I know.
This looks like some kind of coding.
Yeah, it does.
3, 4, 4, 4, 4, 5.
Part B. Use the drawings to complete each statement. The sum of two even numbers is always
Sum of two even numbers is always an even.
right, because in the middle there you've got two evens, and it made 8, which is even. So the sum of two even numbers is always even.
Even. Yeah.
Okay, the sum of two odd numbers
So it's odd.
is always, well, we'll have to look back up here.
Even.
Is even.
Plus. Oh, it's plus. I thought it was times.
The sum of two odd numbers is also always even.
Yeah, because.
Finally, the sum of an even number and an odd number is always
Even.
Even.
Odd.
Well, let's look. What do we have here? 3 plus 4 is
7.
7. 4 plus 5?
8.
Not 8.
9.
9. Those were both odd.
So it's odd.
I'm going to put odd. The sum of an even and an odd is always odd.
That looks like a secret coding with the dots.
I don't know why that box is there. It doesn't say, so I'm just going to draw a little smiley face in there.
I'm just gonna do
Because I did what they said.
I'm just gonna do like a confused
That's
face.
scary.
Yeah, a confused face would be also appropriate.
Could we write?
It doesn't really tell us what to do in there, so.
Or maybe we draw.
Ruben's drawing a confused face.
I don't know how to.
He's
I'm gonna give you
scratching
guys
his
about 10
beard.
more seconds, and then we're gonna go to the
He's
next page.
scratching his beard.
Mine is trying to lick all the letters. Mine is confused.
Okay, it's
That's
been
mine
10
was like
seconds. I'm gonna go to page 85, everybody. What kind of table is this?
It's
Time. Okay. Look at the shaded products in the diagonal of the multiplication table below. Describe the pattern you see in as many ways as possible.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah. Okay. 16. 16.
Do they mean the shaded part? It goes up, down.
Good. I like that.
Mm-hmm.
So the
Do we have to write it?
products increase then decrease.
Yeah.
I'm stuck there.
Could we do first plus then take away?
Or
No, because then they're going to think you don't understand that this is products. They're going to think that you think this is a plus table. So I would keep it increase and decrease.
I
Okay.
did increase.
Yeah. Be careful with that.
Grease.
Okay. So go ahead, Ruben. You did good. That kid noticed something we could write down. Does anyone notice anything else?
It's going odd, even, odd, even.
Yes, that would be the other thing to write. Okay, so it alternates even to odd. And that's about it. I don't really think we can write a whole lot else.
But can we write something else?
If you can find something, I can't really find a whole lot else. I like what we wrote. I think it's good. Gideon?
And that will give us a lot of things.
Yeah, it would get you a lot of points. No, you can look at mine, buddy.
The product is big and small.
And that is it for this packet. Yay!
What?
So long.